I am recording this to address your questions about your test. I'm just being careful not to say your name, just so that if anybody else ever accidentally sees this, it's not a problem. It doesn't reveal any personal information about you. And this is really specifically for your questions. Um, we can meet in office hours. That's still an option, but I thought I would quickly give you some feedback on what I see here going on in your test. So we'll work on solving this one last. And you said it was the empty set. So I guess you kind of hit a roadblock with finding the answers and just assumed that maybe there was no solution. But there is clearly a solution, so we will go over that. Here, this one, I gave you the points back because it's just too hard to distinguish between these two options. They look very much the same to me. So I went ahead and gave you those points back. The next one here, uh, this one was fine. The line is going through, it is hard to see, but you can see that it's going down 1, 2, and it looks like it's going through 3 there. So the slope, the y-intercept is -3. So that was a good choice. You have 2x minus 3 as one of your pieces, so the -3 would be the y-intercept. And then the slope, counting from that point up to another point, you can count 1, 2, 3, 4, 5, 6, and then over 1, 2, 3. So 6 divided by 3 would be 2. So you do have the correct slope there, 2x minus 3. And then the one little dot that's out of place there, because there's a hole in the graph here. So that line piece was only for values of x which are not equal to 3. And you can see that that point is lined up with the x value 3. 1, 2, 3. And I do have my screen at 100%. Another faculty member told me, and I didn't know this, that when you're in the lockdown browser, you can hold down the control key and press the plus sign, and it should allow you to zoom in a bit. But again, even if you can't see it that clearly, you could probably still figure out that it was at x equals 3, and that dot lines up with -2 on the y-axis. So you chose -3 when it should have been -2. So I'm not sure what your reasoning was behind how you chose that option, but I'm willing to believe that you may just have not been able to read it that clearly. So I'm going to go ahead and give you, um, I'll give you half the points for that. All right, now this one, this is an absolute value, so it has the V shape, which is normally at the origin, right? And once you've done transformations on it, it can scoot around and it can get more narrow or more flat and wide. So it is flat and wide, so it was multiplied by something less than 1. So you have a good start to this, choosing 1/4 times the absolute value. And then you did -2 on the outside. That shows that it was dropped down 2 units. So this is below the x-axis. Normally it would be at the origin, so it has gone down. So that was a good choice. Then for the -6 part, that, remember, whenever you have something added or subtracted on the inside with x, it moves the graph the opposite direction of what you would expect. So that is really a 6 because it's x minus h. The minus sign is not included with the value of x. I don't know if you need to see that written out, but the transformation is just the value 6. Whereas out here, this transformation includes the negative symbol. This is actually just inside the x is just a 6. So that meant it would move to the right. So the easy way to remember it is when it comes to the y transformation, you go in the direction you would expect. So for up and down, you would go up if this was positive and down if it's negative. But whatever's on the inside with x, it moves the opposite direction of what you would normally expect. So instead of going towards -6 on the x-axis, you would go towards +6 on the x-axis. So you chose over here when it should have, the vertex should have been in quadrant 4. So if it moved from the origin down and to the right, it would be in this region where your vertex is. So that's why that one's incorrect. And this one here, you have, you did choose, with the negative out front, you did choose a flipped version of the usual square root of x function. So that was good. You have it upside down. That's good. Then you have on the outside +1, so it should have moved up. And I see that you have it below the x-axis. So it should be above the x-axis because it's moved up. And because of the +1 on the inside with x, it should have moved to the left, which you did get that part right on this one. So the only reason you got this wrong is because this should have moved everything up instead of down. And I think that's, oh, here we go. Here's another one. So find the requested value f of 5. So here's the function. It's listed in pieces, and the x value is 5. So when x is 5, that would be x is greater than or equal to 4. So you should use this part of the function. So the answer should just be 5. Right? You always look at whatever x is, see which of these regions it would fall into, and then you know which calculation to use. This one, graph the solution set of the system of inequalities. Okay, I think we need to work on maybe graphing lines, because if you solve each one of these for y and then graph the line, you should end up with this picture. And that's very different from this one. Actually reverse that. That's the wrong answer, and this is the one you should come up with. So start by solving for y. So if I solve this for y, I think I need to show that out, written out in detail. So let me pause and set that up. Okay, so we're going to first take x plus 2y, and we're just going to set it equal to 2 for a moment so we can graph just the line part of it. So I'm going to subtract x on each side, so I'll have 2y equals negative x plus 2. Then I'm going to divide by 2 on each side, so I'll have y equals negative 1/2 x plus 2 divided by 2 is 1. So this is my y-intercept, so that would go for the first line. The y-intercept is 1. Oh, I can't write on that. I have to make a picture of it. Pause again. All right, so we have the y-intercept of 1, and then a slope of negative, so it's going to be going downhill from left to right, -1/2. So I'm going to go down a rise of -1 and over to the right 2. And then since it had a less than or equal to sign, this should be a solid line. All right. Then we can start working on the other inequality. So again, I'm going to start with an equal sign so that I can just focus on graphing the line part. Then I'm going to subtract x on each side to solve it for y. All right, so now I have two lines with both with negative slopes. So as you notice, they both are going downhill. Right here, you chose one that has one going downhill and one that has one going uphill. So one of these lines has a negative slope and the other line has a positive slope. So this one should have a negative slope, a negative slope of 1, and the y-intercept, so you can rewrite this as -1/1 x plus 0, if that helps you see it in slope-intercept form. So now I can go and put my y-intercept at 0 on the y-axis, and then go down one and to the right one, and that'll give me my second solid line, also because the symbol and the equality also had equality in it. Then to choose where to shade. So if you suspect, remember I showed you before that you can actually just solve for y, and whichever way the inequality symbol is facing will tell you where to shade, but you can also do a test point. So if we do a test point, I'm just going to pick any random point. Let's say I used this point over here, which is at 2 for x and 2 for y. So let's do the test point 2, 2. Test point 2, 2. All right, so now I'm going to take the two inequalities and test each one with these points. So I had x plus 2y is less than or equal to 2. So I'm going to replace the x with a 2. I'm also going to replace the y with a 2 and see if this is a true statement. So I get 2 plus 4, and that's 6. Is that less than or equal to 2? No, it's false, right? So shade away. So I'm going to shade away from that first pink line going this direction, shading away from that point, from that test point. All right, then I'm going to try it with the other inequality. X plus y is greater than or equal to 0. So x plus y is greater than or equal to 0. So I get 4 is greater than or equal to 0, which is true. So I want to shade toward that test point from the other line. So here's my other purple line, and I'm going to shade toward that point. And it may help to use a different color, I suppose. Let's use this. So I'm going to shade for this one. Let's use this. It's a little brighter and easier to see. Okay. That's where I shaded before. And now for this one, I'm going to use yellow. And from the purple line, I'm shading toward the test point. Remember, the test point was, I think I accidentally erased it. It was right here. The test point 2, comma 2. And so you can see they overlap in this green region here. And that's why you see that shaded portion there. Okay, and there was one other question that we didn't talk about yet. This part, we have x minus 6y is equal to 9. Then we have negative 3x plus 18y is equal to negative 27. It says solve the system. If the system has infinitely many solutions, write the solution set with x arbitrary. Okay, so let's use process of elimination, or the elimination method. The addition method is what it's called. So I'm going to take a number, let's say I multiply all this by 3, because on the first equation, that'll give me a new version, 3x minus 18y equals positive 27. And now this right here is my new system. And when I combine by adding, so that's why the elimination method is also known as the addition method, I'm going to add up these two, and that's going to give me 0x, or just plain 0. And then these two are going to add up to 0y, or just plain 0. And then these are going to add up to 0. So all of this simplifies to 0 equals 0, which is true. And there are no variables involved. So what that means is that there are infinitely many ways to make this work. Because they actually are the same line. In fact, another interesting thing about this is that if you took negative 3x plus 18y equals negative 27, and divided all the terms by negative 3, in other words, you're multiplying everything, the entire equation, by negative 1/3. Then this cancels to 1. So then you have x. Positive 18 divided by negative 3 is negative 6y. And negative 27 divided by negative 3 is positive 9. So would you look at that? That is the same as the first equation. So these are two lines that actually graph exactly the same way, so they share all points. So any point on one line is going to satisfy the other equation. So how do we write this, though, with x arbitrary? Well, you can see what happened here. They did that. When they said write it with x arbitrary, what you're saying is that it's the set of values where x is picked arbitrarily, and then y is going to be written as a relationship to x, because y depends on x, right? So taking that first equation, because it's simpler to work with, solve for y in terms of x, meaning you're not going to get a number answer, you're going to get an algebraic expression with x in it. So subtracting x from each side, I get 9, whoops, that's not what I meant. Subtracting x from both sides, I'll have negative 6y equals negative x plus 9. Then dividing everything by negative 6, I'll have y equals negative 1 divided by negative 6 is positive 1/6. Positive 9 divided by negative 6, so that would be positive 9 over negative 6, and they're both divisible by 3. So 9 is divisible by 3 times, and negative 6 is divisible by 3 negative 2 times. And so you can see the result is, when it's reduced, y equals 1 times x is x over 6 plus, or actually minus, what happened here? Minus 3 over 2. So when I write my solution set, I'm going to say it's the set of all points, all ordered pairs, where x is picked arbitrarily and y is determined by taking x, dividing it by 6, and subtracting 3/2, and that'll give you the corresponding y value. Okay, so I did my best to answer all of your questions. I'm sure you might still have some. And so after watching this, just let me know if we need to meet. If you would like to discuss any of this in more detail, I'd be happy to meet with you. I hope all is going well. Otherwise, I'm sorry that you didn't do as well as you wanted to on this test.